So this is a part 2 talk. Originally this was one talk which was building an MVP and scaling it. As we had extra time at PyCon, I think one of the previous speakers had pulled out, I've broken up the presentation into 2 parts. The actual part about building the MVP hack was this morning, and this is the part 2. But I'll try and summarize what was said there and move on with that. Additionally, I'm also fine with people just asking questions during the actual presentation. Because this is a part 2 talk, you might have questions or just raise your hand. I often find if people interrupt and ask questions, it adds value to the conversation. And the important thing about this talk is that I add value because your time is valuable. So the previous talk, I talked about building an MVP hack in Django. The idea behind the hack was that you could upload a PDF or text document and then ask a large language model about it and get some sort of sane response. To make it financially viable, the idea was that it was supposed to support confidential documents such as medical documents or financial documents. So you have to be able to self-host everything. If you don't have this requirement, then of course you can just throw everything into a big tech giant and they will do it for you. And there's no way as a startup you can compete with a big tech giant with those kind of behavior. So the original architecture worked in this way, that you get a bunch of PDF documents, the user would upload them, and they would pass to a Django worker. We do all the actual background work on the Django worker as part of our hack, which is hacky, but it was just to get something out very, very quickly. So specifically, the Django worker would have endless blocking processes, which would take the PDF, read verbatim the actual text from it, cut it up into pieces, and then send the information into an embedding service, which would extract the semantic meaning. That would then get stored into the vector database, which we used ChromaDB. Then when the actual user asks a question, that will be sent to the Django worker, converted to semantic meaning, then that will be used to query the vector database, to pull out text chunks which are relevant to the conversation, hopefully, and then that will be passed to the large language model and then sent all the way back. So you can see a pattern here. Everything goes by the Django workers, and the way we made it work is we used a decorator called sync to async. This essentially allows you to spin off blocking processes and have them run in the background as a coroutine, assuming that they are thread insensitive. So this hack, there's a lot of value in a hack because it gets it into the user's hands and it gives it to, you can give it to a product manager who will get in front of people and give you a very quick iteration cycle. Ultimately, you do not want to spend a lot of engineering time building things that will not get used, don't have money behind them, especially in the circumstances you are now, which is that AI technology moves so incredibly quickly, you have to be able to adapt, plug things in as the market changes. So there are a couple of things we want to do when moving from our hack into production. One is switching out from ChromaDB to a better vector store. One is to move all the pre-processing and document processing from the Django workers into dedicated pipelines. One is another thing is to actually self-host the large language models rather than use a dedicated service. So for the MVP hack, well, we knew we had to be able to self-host, so we chose models such as Llama 2, which we knew we could self-host, but we did use Replicate to show that the actual responses and the process worked for us. We want to also migrate the Django templates to a dedicated React app, and we also want to add embedded monitoring and logging. So the main change is essentially we want to offload a lot of the work we've done on the Django workers onto dedicated processing pipelines. That whilst you can run jobs asynchronously on the on the underlying workers, you'll run into a number of issues. Main thing is that you can overload your entire workers. Second thing is also just you can often get clashes in how you start to actually build things out. Also, I don't want to add in some more extra useful things, such as using S3 storage rather than storing files in a shared volume. So S3 storage isn't just for convenience. It actually the version that often comes by default in S3 storage can be extremely useful. We had a production issue at one of the previous companies I worked at, where one of the devs had messed up how the UUIDs are built for documents. So when multiple users started to upload documents, they ended up clashing and overriding each other. If we had just used a volume-mounted storage for that, we would have lost all the data. The S3 data was overwritten, but we had versioning, so we were able to work backwards and restore things. And like I said, we also want to move from ChromaDB to a better vector database. We can also partition things off if we want to be fancy. So when we self-host our large language model, we can also add in something like JWT authentication and have it directly communicate with the users by using JWT auth. So then it's a partitioning responsibility. Let Django do all the business logic and let all the other services such as the LLM perform their dedicated specific functionality. So for the data processing pipelines, the idea is you want to get things off the Django worker and run it separately. A common way of doing it is using Celery, and behind Celery is a message broker. A common one is RabbitMQ, and it's what we used because it was rock solid. A message broker is basically a postman or a post person. It takes a message, usually binary encoded JSON, and it's its responsibility to deliver it to the next stage, i.e. the consumer. For this, Pydantic is insanely useful because if you're writing encoding a lot of JSON, you can specify the format for it in Pydantic and then import it into different projects. And you end up catching a whole host of errors. Other developers come onto the team and start writing things. Also, writing serialization and deserialization of JSON by hand and validation is insane. It's a waste of time and it's insane to do it. As I said, the magic behind a lot of these data processing pipelines is a message broker and one that's rock solid. So let's say I decided a different approach, which was just to set up a bunch of microservices and have them talk via webhooks, where they just basically do a post to each other. What happens if you lose a message or a microservice goes down? Or how do you scale that? With the message brokers, literally, let's say Django publishes a message that please take this PDF I've uploaded and extract information from it. The responsibility of the message broker is to basically take that message and try to deliver it. It also offers queuing functionality, so it can queue across multiple workers. If a worker fails or message is not delivered, it's the responsibility of the message broker to retry delivery. If it fails multiple times, to record it as a dead letter. Now, again, going back, so I'm talking about refactoring things, about things that will break. So we're expecting users to upload PDFs, but what is a PDF? Turns out it's a very, very old format, and there's very weird versions of it. So your initial users will probably upload things which look quite nice, and you can extract the text from it. Then as you scale, people will upload horrible things dug out from the 1990s. So the trick with that is to not trust your PDF. You take your PDF and you convert it to an image and you OCR that. So that's where these pipelines come in. So you OCR it. Then from the OCR, you extract text. You want flexibility in your data pipelines because your initial candidate might have been extract text, run queries on it, but it turns out your user are actually financial organizations. There's charts in your PDFs, so you actually want to extract information from those charts. So you want to be able to set up pipelines where one pipeline triggers another, and you extract maybe the initial OCR and the text, but then you also look for charts and you extract information from those. So you want to have a lot of flexibility in your processing pipelines. You want to keep them reliable, and you want to keep them simple and human readable amongst multiple developers. Because you will have developers boarding your project, onboarding and offboarding as they join your organization and leave. So Pydantic was very useful for that. So the usual way for building out asynchronous work in Django is to just stick Celery in it. Celery is a wrapper around a message broker, usually around MQ. It integrates really nicely into Django, and the way it works is it usually just spins up a Django worker, which loads all the Django dependencies, and it's really nice for getting started because you can connect to the database and do business logic. The problem is next when you have to scale from that. As I've said, you don't want to trust your PDFs, you want to run OCR on them. Then you probably want to run some machine learning. And at some point, doing pip install, numpy, PyTorch, SciPy, scikit-learn, you will end up in dependency hell, and the whole thing will go phew. Now, where it really matters is specifically the Django side. So Django is exposed to the internet via reverse proxy. So you need to keep your Django dependencies up to date, or reasonably up to date, and ideally I recommend running pip audit for package dependencies. If you're running something like on financial documents, you will need a security audit, and pip audit is part of that. So when there are security issues, you will need to be able to update your dependencies, and that means essentially being able to update Django and its poetry dependencies. So what happens at that stage is you need to generally separate out your data processing pipeline. That you may have things that Django Celery runs, but then you want to send out and run separate processes which listen for messages and only load up exactly what's needed. So it's usually a Docker containing running a specific version of PyTorch, and those kind of things. You have to be aware that you can't just load everything into Django Celery and expect it to work. Things will blow up, and you will need to plan for refactoring. So I also talked about moving away to a better vector database. So ChromaDB is just a wrapper around SQLite, which does vector search. So it's not just that you care about performance, but you care about better search. Let's say your business case is that your support hotline for IBM, and what you care about is IBM ThinkPads. So you'll take maybe 100 PDFs of different IBM ThinkPad laptops. You put them through the process, you embed them, and you stick them into a vector database. Your user then comes in and asks the chatbot, hey, how do I replace the BIOS battery on an IBM ThinkPad? So what will happen is the vector database will basically look for the semantic meaning of that specific laptop model and BIOS. Maybe the first match is correct. It finds the correct manual and pulls the text from that. The problem is subsequent text searches, that it might pull out information from different PDFs, from different manuals, and then that information is passed to the large language model, and the AI gets confused because you're feeding it garbage. So you need a dedicated way to be able to control how you retrieve information from a vector database. That similarity is not enough. So the way I've seen it done is that people have moved to Elasticsearch or OpenSearch for hybrid or ranked recall, where you can start to sort of do more custom recall, so based on keywords and custom ranking. And I should also note this is very specific to the type of documents you're working with. If you're working with specific forms of financial documents, they'll retreat differently to IBM ThinkPad manuals. And to my knowledge, there's no general way to get RAG to work in a general manner across all information. That it does require about a play here and there, And so it's useful to have a Django interface where you can run these queries and see how the results come out. So the initial UI that I built for this was very straightforward. Let's see if I can go backwards to show you it. Looked a bit like that. Ugly, simple, but it was just done using the Django templated language, some JavaScript, very quick to get going. The problem with this is you'll run into the fact that the front-end client does need a bit of state. Let's say a user uploads 20 PDFs at once by drag and drop. As each of those upload, you want kind of like a little button that sort of changes. You don't want the entire UI to just refresh. You want the state to operate consistently. And you can't do this just with vanilla JavaScript. Not just because the code gets more complicated, but also because it's almost impossible to test. So anything of complexity, you need to build unit tests for, unless you're considerably smarter than me and can just do it in your head. Turns out if you want to test in JavaScript, the way to do it is Jest, and Jest requires Webpack. That means basically you may as well use a JavaScript framework. There's a lot of different JavaScript frameworks out there. The reason we use React is because it's the modern day jQuery. jQuery is an ancient JavaScript library. It's been around for 15 years, and it'll still be sitting around in corporate code bases for the next 15 years. And I think React is something similar. People are writing it, once it's in production, it'll stay there for the next 10, 15 years, until something replaces it in maybe 4 or 5 years. React is a bit of a beast. Not React itself, but I think the tooling around it. Specifically, Webpack is hell. They tried to fix it with the Create React app, so you could spin up a React application quickly with Webpack behind the scenes and just out of the box. They didn't appreciate it 2 years ago, and it's a mess now. But from the Django side, what helps a lot is that if you're using Django Ninja or even Django the REST framework, you can auto-generate TypeScript schemas and APIs from the Django API. This saves a huge amount of time, and it tightly couples your UI to the backend. This is of course a design decision, but fundamentally, if your UI cannot run without the backend, because all your business logic and native is there, your UI is by de facto tightly coupled. So from the backend with Django Ninja, you provide a schema, which is just a Pydantic schema, similar to what you have with Fast API. That's your schema. That generates a Swagger UI and also an open API schema, which you can then consume. So I used Open API TypeScript CodeGen. It basically sucks up the Open API schema, writes it to a file, and then outputs both the Axios promise and the types for it. And it saves so much time and catches so many bugs. I really, really loved it. So as we're coming up to the end of the talk, I want to give you some code examples. So the initial MVP hack I built is here for Fast API, for Django's here. If you want to take a look about working with Celery for document processing as part of Django, I recommend this GitHub repository. There's a lot of good code examples in there. As far as I could tell, they still run everything on top of Django workers, but it's a great way for actually seeing quite a large code base using Celery. And my LinkedIn profile. Finally, I'm based in Warsaw. If you come to Warsaw, it's an amazing city. I'm involved in 2 projects. AI Code and Coffee. It's a meetup that runs once every 2 weeks. Developers grab a laptop, buy a coffee, and we work through AI topics. The second is there's a big conference running in November called MLMPL. It's academically focused, so there's a lot of AI researchers. I went last year, the quality of talks was extremely high, and I highly recommend it. Additionally, I want to thank the organizers of PyCon Lithuania. It's it's a lot of work to organize a conference like this. It's stressful, a lot of work, and I'm really grateful for the opportunity to talk. Any questions?
There are no questions in the chat, but maybe any live questions.
Yes, thank you very much. Very cool things. How much of these were you able to do yourself versus having to delegate or get help for them? Because there's such a broad range. For example, self-hosting the LLMs versus doing TypeScript or the UI, or there's so many different things. Was it all your skills, or was it?
I can give you time. I can even tell you time, because so I use GPT-4 to track time and for the whole process. So the fast API hack took about 10 hours. The Django hack took about 90 hours, and I did it all myself. I was using GPT-4 to summarize my Git commits. It turns out that it's actually pretty good. If you paste your Git diff into GPT-4, it generates something sane. Sometimes you have to fix it, but it's a good way of tracking things. So I had to do it all myself. Again, this is a non-commercial project. I just did it in my spare time to see if it's to keep up with the tech. But it's also the expectation of devs has changed, right? So everybody traditionally wants a full stack dev. You can also do some DevOps. But now the expectation is full stack plus DevOps with some ML experience. And in 2 years' time, we want an ML engineer who can also do full stack web development. This is also why I run the AI code in coffees, because I can study in my spare time, but it doesn't stick in my head unless I basically have interaction like this. People asking questions, it sticks, we talk and we learn. But it is pretty insane, but at the same time, the AIs also compensate a lot. Some of the niche details, such as how do I mock this test correctly, how do I test a Django admin, GPT-4 got me 90% of the way.
Any more questions?
One more question. So you use the vector database to sort embeddings and things like that. What's the impact of this? Does you use it only for the acceleration of the inference?
The destination?
Acceleration of, to get the inference results faster. Why
no, so we use the database for semantic meaning, right? Yeah. So when you've got a large language model, like the early layers extract semantic meaning, that they basically, you take bunches of text and it tries to map it internally to a vector. So if you have a paragraph that talks about taking your dog to the vet, it sort of in its own vector representation understands it's something to do with animal and medicine. And so when a user asks a question about, I don't know, how do I replace my ThinkPad laptop battery, it will ignore that. It will look for things that are more technical than that. So it's about retrieving, it's about organizing and retrieving information that we hope is semantically similar. Does that sort of make sense? Yeah. And the reason we can't just throw the entire document in is usually context length is context windows are too short. Don't get me wrong, context windows for large language models are getting bigger, but they will never be, they're unlikely to be infinite. There are always more documents than the context window. Additionally, some of the larger context windows are grossly misleading. So Cloud, I think, said had a 200K context window. And what you can do is you can do like a needle test where you take like a big book, you upload that, but at very specific points, you add in weird bits of information. I don't know, it could be it could be Lord of the Rings, but you put in somewhere a little bit about Django, that kind of thing. And then you ask the large language model to recall. So what they did is that it showed, there's a paper out there that there's certain gaps in the memory. I think it's either towards the end or towards the beginning, where the retrieval doesn't actually work very well, even with very large context sizes.
Do you know the reason why?
No.
The beginning and end?
It was a paper I think came out a month ago. You can just find out on Google. It's interesting.
Okay, I think we have time for one more question if there are any.
If you would have a much lower limitation on rank token limit, let's say much smaller, would you choose some kind of architecture decision?
So because you're using like a smaller model.
Yeah.
So then it's just fine tuning. So basically what you actually pull out of the vector database. So a lot of this is very sort of depending on the data you're throwing into it. So that's what I'd optimize. A common optimization though is actually earlier in the stage. So let's say you've got a chat interface that's exposed to the internet, and your user decides, and I don't know, you've got a car website and you want the user to ask about cars, and instead they type in and they ask something completely different. The way you've handled that is you have a much simpler model which does one-shot classification. And it takes the initial user input and says, is this about cars or not? And if not, it rejects it. So that's a way to sort of save money from using a larger model.
We're out of time. Can you ask individually? Sorry about that. So yeah, let's give a round of applause.